The function which is going to maximize or minimize is called the objective function, and this function is usually denoted by capital letter Z. 0, 0, A. What is A? A is 0, 50, and what is E? E is 20, 30, and D. What is D? D is 30, 0. These are the corner points. Just convert the inequalities into the equalities. So the given equation can be written as 4x plus 2y is equal to 20. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty department of mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss very important 5 marks question for the point of examination, that is solving a linear programming problem by graphical method. So solving a linear programming problem by graphical method. So in the examination for 5 marks, they will ask one question: solve the given LPP graphically. Now let us discuss the step-by-step procedure to solve the linear programming problem by graphical method. Now, so how to solve this? Before going to that, let us know regarding general linear programming problem. What is meant by a general linear programming problem? A problem in linear programming is formulated mathematically by first identifying a set of decision variables. So that is, say x1, x2, x3, etc., xn, which are subjected to certain linear constraints written in the form of an inequalities, like a11 plus a12 into x2 plus a1n into xn less than or equal to or greater than or equal to b1. Similarly, a21 x1, a22 x2 plus etc. a2n xn, which is less than or equal to or greater than or equal to a constant b2. So therefore, we will write am1 x1 plus am2 x2 plus amn xn, which is less than or equal to or greater than or equal to bn. So let us discuss like this, where the coefficients a, I, j and b1, b2, b3, etc., bm are constants, and the non-negative restriction, the non-negative constants are given by the equation x1 is greater than or equal to 0, or x2 is greater than or equal to 0, etc., xn is greater than or equal to 0, right? So the aim of this mathematical formation is to optimize a linear expression. So that is z is equal to c1x. So z is equal to c1x1 plus c2x2 plus c3x3, etc., cnxn for given constants c1, c2, and for given constants c1, c2, etc., cn. This is called the objective function. So z is equal to any equation of the form c1x1 plus c2 x2, etc. is called an objective function, which is to be maximized or minimized, is called the objective function. Thus the optimization, that is maximization or minimization of the objective function, is called as the general linear programming problem. So just the objective function, thus optimization means the maximization or minimization of the objective function is called general linear programming problem. Now let us discuss some important definitions in this linear programming problem, that is structure of linear programming model. So the general structure of linear programming model consists of 3 basic components or elements. First one is a objective function. Objective function is nothing but this is the function which is to be maximized or minimized in the problem. The function which is to be maximized or minimized is called as the objective function, and this function is always denoted by z. That is, this function is always a linear function consisting of the variables, and it is denoted by z. Capital Z is the objective function. That means the function which is to be maximized or minimized, that is called optimized. Optimized means maximized or minimized. The function which is going to maximize or minimize is called the objective function, and this function is usually denoted by capital letter Z. Now decision variables. What is decision variables means? These are variables which affect the value of the objective functions. These variables are denoted as x1, x2, x3, etc., xn. So x1, x2, x3, etc., xn are called as the decision variables. Now, the third very important is the constraints. What is this constraint? Means these are the condition existing with regard to the decision variable. These constraints will be in the form of a linear inequalities. Constraints. These are the condition existing with regards to the decision variables, and these constraints will be in the form of a linear inequalities. Thus, a linear programming problem is one that is concerned with finding the optimal value. So, linear programming problem is nothing but finding the optimal value, that is the maximum or minimum value of a linear function called the objective functions of several variables. Several variables may be x and y. So, subjected to the conditions that the variables, right. Now, also there are some important terminologies or some important definitions. What are these definitions? Feasible region. Feasible region means the common region determined by all the constraints, including the non-negative constraints x comma y greater than or equal to 0 of a linear programming problem is called the feasible region or solution region. That is very important concept. The common region, it is a common region. The common region determined by all the constraints, including the non-negative restrictions of a linear programming problem, is called the feasible region, or it is also called as the feasible solution of the problem. The region other than the feasible region is called as the infeasible region. So, that is the common region determined by all the constraints, including the non-negative restrictions, is called as the feasible region of the given linear programming problem. Now, the second definition is feasible solution. What is this feasible solution? A solution which is a set of real values which satisfies all the constraints is called as the feasible solution. A solution which is a set of all real values which satisfies all the constraints is called as the feasible solution. Optimal solution. Any point in the feasible region that gives the optimal value. Optimal value here means the maximum or minimum value of the objective function is called as the optimal solution. So, optimal solution means any point in the feasible region, any point in the feasible region that gives the optimal value, maximum or minimum value of the objective function is called as the optimal solution, right. So, these are few important definitions which we are going to study while solving this linear programming problem. Now, let us discuss the graphical method of solving a linear programming. So, this is very important method. Graphical solution for linear programming problem. So, what is the graphical method? The graphical method of solving a linear problem consists of the following steps. Find the feasible region of the linear programming problem and determine its corner points. So, that is corner points are nothing but the vertices, either by inspection or by solving the two equations of lines intersecting at that point. So, first find out the feasible region of the linear programming problem and determine its corner points, that is nothing but the vertices. Determine the vertices, they are called the corner points, either by inspection method or by solving the two equations of lines intersecting at that point. Next, evaluate the objective function z is equal to ax plus by. Evaluate the objective function that is given by z is equal to ax plus by at each corner points. Let m and capital M and small m be the respectively denotes the largest and smallest value of these points. Then, so when the feasible region is bounded, m and m are the maximum and minimum value of z. So, in case the feasible region is unbounded, we have, what are the condition? M is maximum value of z if the open of plane determined by the equation ax plus by is greater than m, has no point in common with the feasible region, otherwise z has no maximum value. That is, if m is maximum value of the function z if open off of the plane determined by ax plus by is greater than m. If it is greater than m, has no point in the common with the feasible region, otherwise z has no maximum value. Second condition, similarly, if m is minimum value of z, If the open of plane is determined by ax plus by is less than m, here it is capital M, it is greater than m, here it is less than m, has no point in common with the feasible region, otherwise z has no minimum value. So, let us illustrate this by taking an example by the method of yes, corner point method by considering some examples. Now, let us take a few examples based on these points. Now, let us solve. This is very important type. In the examination, they will ask one 5 marks question like this. It is a 5 marker question. Yes, solve the following linear programming problem using graphical method. So, what is the given condition here? Maximize. So, the problem is to be maximized. Maximize z is equal to 4x plus y subjected to constraints x plus y is less than or equal to 50, 3x plus y is less than or equal to 90 and x is greater than 0 and y is greater than or equal to 0. Now, let us convert these inequalities into equalities. So, let us convert this into equal, that is equality. So, inequalities into equal equations, that is equalities. Now, the given equation can be written as x plus y is equal to 50. Another equation is 3x plus y is equal to 90. Okay. Now, converting the first inequalities into equalities. Now, let us solve this equation. Now, from this x plus y is equal to 50. Now, put x is equal to 0. If you put x is equal to 0, you will get y is equal to 50. Therefore, the point, let us call it A is equal to x comma y 0 comma 50. Now, again put y is equal to 0. If you put y is equal to 0, you will get x is equal to 0 plus 50 is 50. So, therefore, another point B is equal to x is 50, y is equal to 0. X comma y are the coordinates. Similarly, second equation 3x plus y is equal to 90. If you put x is equal to 0, y is equal to 90, then the point C is equal to 0 comma 90. Similarly, put y is equal to 0. If you put y is equal to 0, what you will get? 3x is equal to 90, x is equal to 90 by 3 is nothing but 30. Therefore, the other point D is equal to 30 comma 0. Right. So, therefore, what are the points we got here? So, for the first equation, x plus y is equal to 50. These are the points. So, x, y. When x is 0, y is 0. When x is 0, y is 50. When y is 0, x is 50. This is for equation number 1. Another equation, second equation is 3x plus y. 3x plus y is equal to 90, equation number 2. For this, what are the set of values we got? So, here it is x and y. When x is 0, y is equal to 90. When y is 0, x is equal to 30. So, these are the points. Now, let us plot a graph of this. Now, this is x axis, y axis. Now, let us take the scale on x and y axis, 1 centimeter is equal to 10 units. Okay, 1 centimeter is equal to 10 units. Let us start with this 0, 10, 20, 30, 40, 50, 60. Then again 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. So, each centimeter is equal to 10 units. Now, let us take each centimeter, 1 centimeter is equal to 10 units, 10, 20, 30 like this, 10, 20, 30 like. Now, what is the first point? When x is 0, y is 50. When x is 0, y is 50. 0, 10, 20, 30, 40, 50. Call it as A, 0 comma 50. Next, second point, when x is equal to 50, y is equal to 0. When x is equal to 50, y is equal to 0. When x is 50, 10, 20, 30, 40, this is 50, y is 0. Another point, this is B, 50 comma 0. Now, just draw a straight line just intersecting these 2 points. So, this is. Now, what is this equation? The first equation is x plus y is less than or equal to 50. So, this is x plus y is less than or equal to 50. Now, just since if it is less than or equal to 50 means the feasible region is towards the origin. This is towards the origin. See, if you put x is equal to 0, y is equal to 0, 0 plus 0 is 0, which is less than or equal to 50 is true. So, therefore, the feasible region is towards the origin. Now, let us move on to the second curve. Now, what is the second curve? When x is equal to 0, y is equal to 90. When x is 0, y is equal to 90. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. This is the point. Call it as C 0, 90. When that is C 0, 90, D 30, 0. When x is 30, y is equal to 0. This is the another point D 30, 0. Draw a straight line which passes through C and D. This is the line. Right. Now, what is this curve? That is nothing but second equation is 3x plus y is less than or equal to 90. Write down the line. What is the line? 3x plus y less than or equal to 90. Here also, if you put x is equal to 0, y is equal to 0, 0 plus 0 is 0, which is less than 90. So, the feasible region is towards the origin. So, the feasible region is towards the origin. Now, just shade. So, this is the feasible region. Now, the corner points. So, these are the corner points. So, therefore, the corner points are O, this A, then let us call it as E and D. Now, find out the value of E. What is E from this diagram? So, just find out E. So, if you draw like this, so this is equal to x is equal to 20, y is equal to 30. 20, 30 is the point E. Therefore, the corner points are O 0, 0, O 0, 0, A. What is A? A is 0, 50, and what is E? E is 20, 30, and D. What is D? D is 30, 0. These are the corner points. Now, substitute here and find out the value of maximum value Z. Okay. Now, I will do here the corner points. And Z is equal to, what is the objective function? Z is 4x plus y. 4x plus y. Right. Now, at O 0, 0, when x is equal to 0, y is equal to 0, z is also equal to 0. At second point, at A, capital A 0, 50, at A 0, 50, this is 0 plus 50, this is equal to 50. Again, at another point, take D. What is D? D is equal to 30, 0. At 30, 0, 4 into 30 plus 0, that is equal to 120. And the last point at E, what is E? E is equal to, E is what we have 20, 30. 20, 30. So, this is equal to Z 4 into 20 plus Y is 30. 4 into 2 is 80. 80 plus 30 is 110. So, these are the values. So, at the corner point, O 0, 0, Z is 0. At A 0, 50, the maximum value is 50. At D 30, 0, the maximum value is 120. At E, the value is 110. Now, what is to find is the maximum. What is the objective function? To maximize. So, maximize is the objective function. What is the maximum value? So, the maximum value is 120. This is the maximum value. So, therefore, the maximum value is 120. So, conclude this. Therefore, Z maximum is equal to 120 at 120 at 30, 0. This is the maximum value of the given linear programming problem. That's it. This is how we are going to solve a LPP problem, graphical method, by graphical method. Okay, hope you follow. So if you solve this much, definitely you will get 5 marks. Now let us take a similar type problem. Move on to the next problem. Same type. Solve the linear programming problem by graphical method. Minimize z is equal to 200x plus 500y subjected to constants. X plus 2y is greater than or equal to 10. 3x plus 4y is less than or equal to 20. And the non-negative restrictions, x is greater than or equal to 0 and y is greater than or equal to 0. Now let us convert these inequalities into equalities first. Now converting the inequalities into equalities, the given equation can be written as given equation. So x plus 2y is equal to 10. Another one is 3x plus 4y is equal to 24. Right. Now let us solve this. So first equation, x plus 2y is equal to 10. Put x is equal to 0. Then you will get 2y is equal to 10. Y is equal to 10 by 2 is 5. So therefore the first point a is equal to 0 comma 5. Similarly, put y is equal to 0, then x is equal to 10. So therefore the second point b is equal to 10 comma 0. Similarly, take second equation, that is 3x plus 4y is equal to 24. Put x is equal to 0, then 4y is equal to 24, y is equal to 24 by 4, that is equal to 6. So y is equal to 6. So therefore c is equal to 0 comma 6. Again put y is equal to 0, then this 3x is equal to 24, x is equal to 24 by 3. This is equal to 8. So therefore x is equal to 8. So therefore the point D is equal to 8 comma 0. Okay, that's it. So these are the points. Now just by taking these points, draw a graph and find out the feasible region. You will get the feasible solution. That's it. Okay. Now let us represent these points on a graph. This is x-axis, y-axis, this is 0. Now let us consider a suitable scale. Scale on x and y-axis, 1 centimeter is equal to 1 unit. Okay, each centimeter is equal to 1 unit. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. Now just take first point. What is A? A is 0 comma 5. What is B? 10 comma 0. A 0 comma 5. X is 0, y is 5. 1, 2, 3, 4, 5. This is A 0 comma 5. B 10 comma 0. X is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is B 10 comma 0. Now just represent, draw a straight line which cuts A and B. So this is the straight line. Okay. Now what is the equation? X plus 2y is greater than or equal to 10. So this equation is x plus 2y is greater than or equal to 10. See, if you put x is equal to 0, y is equal to 0, since the inequality is greater than or equal to 0 means the feasible region is away from the origin. So that is out of this. So away from the origin. So suppose if you put x is equal to 0, y is equal to 0, 0 plus 0 is 0, 0 is less than or equal to 10, not greater than or equal to 2. So therefore this is false. Hence the feasible region is away from the origin. This is the feasible region. Here we are going to get the feasible region away from the origin. Now the second curve. Now what is the second curve? We have C 0 comma 6. When x is 0, y is 6. This is 6. 1, 2, 3, 4, 5, 6. C 0 comma 6. Again D, what is D? 10, 8 comma 0. 1, 2, 3, 4, 5, 6, 7, 8. This is 8. D 8 comma 0. Now just draw a straight line which cuts the point yes, C and D, these 2 points. So this is the line. Okay. Now what is this equation? This equation is nothing but 3x plus 4y, 3x plus 4y is less than or equal to 24. See, suppose if you put x is equal to 0, y is equal to 0, 0 plus 0 is less than or equal to 24, which is true. So, since it is less than or equal to means the feasible region is towards the origin. So, the feasible region is towards the origin. So, in this direction we will have the feasible region. Therefore, the feasible region is, this is the feasible region. Now, so this is the point of intersection. What is this equal to? So, what you will get exactly? This is 4 comma x is this is the feasible region. X is equal to 4, y is equal to 3. So, therefore, the corner points are what are the corner points? We have A 0 comma 5, then C 0 comma 6, and E, what is E? 4 comma 3. So, these are the corner points. Now, find out the maximum and minimum value for this function. Now, at corner points, what is given? Z is equal to what is objective function? 200x plus 500y. 200x plus 500y. Let us check what we are going to get for this. At 0 comma 5, at A 0 comma 5, z is equal to 0 plus 5 into 500, that is 2500. Next, at what is the point? At A, this is C, this is C, at C 0 comma 6, 0 plus 6 into 500, that's equal to 3000. Again, at E, what is the point? 4 comma 3. So, 200 into 4 plus 500 into 3. So, 4 to the 8, 800 plus 1500. This is equal to 2300. Right, 2300. Now, what is the objective function? So, minimize. So, we want to find the minimum value of this. Which is the minimum value? 2300 is the minimum value. So, therefore, minimum value, this is the minimum value. What is the answer? Therefore, Z minimum is equal to 2300 at 4 comma, that's all. This is how we are going to solve this LPP. Hope you followed. Right, that's it. Okay. Move on to the third problem. Minimize Z is equal to 6x plus 8y subjected to 4x plus 2y less than or equal to 20. 2x plus 5 is less than or equal to 24 and x comma y is greater than or equal to 0. Now, just convert the inequalities into the equalities. So, the given equation can be written as 4x plus 2y is equal to 20. Another equation 2x plus 5y is equal to 24. Let us solve these two equations. Put x is equal to 0 and y is equal to 0. If you put x is equal to 0, then you will get 2y is equal to 20. Y is equal to 20 by 2 is 10. So, therefore, the first point A is equal to 0 comma 10. Similarly, put y is equal to 0. If you put y is equal to 0, then what you will get? 4x is equal to 20, x is equal to 24, 20 by 4. So, that is equal to 5. Right. Therefore, the point B is equal to 5 comma 0, x is equal to 5 here. Now, so therefore, for the first equation, what we got? 4x plus 2y is equal to 20, right? When x and y, when x is 0, what is y? Y is 10, right? When y is equal to 0, x is equal to 5. 0 comma 10 and 5, 0 are the points. Now, similarly for the second curve, put x is equal to 0. Then what you will get? Y is equal to 24 by 5. You can't divide it. Therefore, C is equal to 0, 24 by 5. Similarly, put y is equal to 0. If you put y is equal to 0, 2x is equal to 24, x is equal to 12. The point D is equal to 12, 0. Now, for the second curve, what is the second curve? 2x plus 5y is equal to 24. What are the points? X and y. When x is 0, y is 0. When x is 0, y is equal to, when x is 0, y is equal to 24 by 5. And when y is 0, x is equal to 12. So, these are the points. Now, let us draw a graph for this. So, the graph is x-axis, y-axis 0. Now, what are the values we have? Let us consider each value is equal to 1 centimeter is equal to 1 unit, same as usual. Scale and x and y-axis, 1 centimeter is equal to 1 unit. This is the scale. Now, just write 1 centimeter. 1, 2, 3, 4, 5, 6. Okay. Now, draw the graph. So, when x is equal, yes, first point A, when x is equal to 0, y is equal to 10. When x is 0, y is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is A, 0, 10. B, what is B? When x is 5, y is 0. X is 5. 1, 2, 3, 4, 5. B is 0. That is, when x is 5, y is 0. This is B, 1, 2, 3, 4, 5. Now, draw a line, draw a straight line which joins these 2 points A and B. So, this is the straight line. Okay. Now, what is this curve? The curve is 4x plus 2y is less than or equal to 20. Since as usual less than or equal to 0 means the feasible region is towards the origin. Check, if you put x is equal to 0, y is equal to 0, 0 plus 0 is 0, which is less than 20. Therefore, the feasible region is towards the origin. This is the feasible region. Now, the second curve. What is the second curve? See, when x is equal to 0, y is equal to 24.5 means this is nothing but 0, 4.8. That's it. 24 by 5 is 4.8, less than 5. So, when x is 0, y is 1, 2, 3, 4, 5, just less than 4. 5 is, this is C, 0, 4.8. And D, what is D? D is 12, 0. X is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is D, 12, 0. Now, just draw a straight line which cuts these 2 points. That's it. And what is this curve? This is equal to, that is 2x plus 5 is less than or equal to 2x plus 5y is less than or equal to 24. So, here also less than or equal to 24. If you put x is equal to 0, y is equal to 0. If you put x is equal to 0 and y is equal to 0, what happens? 0 plus 0, which is less than or equal to 24. Less than 24 is true. So, therefore, the feasible region is towards the origin. So, this is the feasible region. So, where it will meet, this is the point where it will meet. So, therefore, this is the feasible region. So, this point is considered as E. What is E here? So, this is the value. So, if you solve this, definitely you will get, this is 3.2, 3.5. So, E is equal to 3.2, 3.5. So, therefore, the corner points, what are the corner points? Therefore, corner points are O, 0 comma 0, that is 0 comma 0, and then C. What is C? C is 0 comma 4.8. Then E, what is E? To 3.2 comma 3.5, and this point, that is, and B, that B is equal to 5 comma 0. So O, these are the corner points. O, C, E and B are the corner point. So therefore, at corner points, what is given? Z is equal to, what is the objective function? 6x plus 8y. 6x plus 8y. Substitute here. So at O 0 comma 0, Z is equal to 0. Next, at C 0 comma 4.8, this is 0 plus 8 into 4.8, that's equal to 38.4. 38.4. Again at E, what is E? 3.2 comma 3.5. Z is equal to 6 into 3.2 plus 8 into 3.5. What is this equal to? This is 19.2 plus 3.5 into 8. This is equal to 28. If I add these two, 47.2. And the last one at B. At B, what is B? We have 5 comma 0. This is 6 5s are 30 plus 0, that's equal to 30. Now what is to find is, what is the objective function? Minimize. The minimum value is to be determined. What is the minimum value? So the minimum value is 30. This is the minimum value. So minimum is 30 is the minimum value. Okay. So therefore the minimum value is 30. So you can conclude like, so therefore I can write here, therefore Z minimum is equal to 30 at 5 comma 0. That's all. So Z minimum is equal to 30 at 5 comma 0. This is the solution. This is how we are going to solve a linear programming problem using graphical method for 5 marks. Okay. So hope you followed all these problems. Very important, just practice very simple problem. Definitely will get 1 5 marks question from this. So hope you followed this type of problems. Now that's all regarding today's session. Let us meet with a different concept in the next session. Thank you very much.